All right, very first thing that you're going to want to do is make sure that you have the original problem written down in your notebook. And you notice that it has a few different directions. It has for you to identify the method of solving the quadratic equation, and then to explain why you chose it, and then, of course, to solve it. Okay, so there's a few different things that you need to do. Here are the different ways that you can solve a quadratic equation, at least the ways that we went through in class. One is taking the square root. Don't worry, I'll go back to that. Taking the square root. It'll help. Another is completing the square. Another is factoring. And then another, of course, the last one that we went through is using the quadratic formula. Technically, the quadratic formula can work anytime for any situation. But it's kind of overkill if you can factor. It's almost as if, you're doing way more than you need to be able to find out what the answer is. So here are our choices of how to solve a quadratic equation. Each one has different situations that would help us the best. So I'm going to start with factoring. You always start to see if it's factorable. So reasons why you would solve by factoring is, well, first off, it might not have too many factors. Not too many factors. Or it's factorable. Right? If it's factorable, then it absolutely would be a reason why you solve by factoring. Or it has no value for C, no constant. No value for C, no constant. Right? So there's just numbers that are in front of the x squared terms, or the x, but no constant. No value for C. Okay, then after you check to see if it's factorable, you check to see if using the method of taking the square root would work. Okay, so reasons why you would use that method: b equals 0. That's the number in front of the x term is equal to 0, or you don't even see the x term. Other reasons why you would solve by taking the square root: you already have, or it's already expressed as a binomial squared equal to a constant. A binomial squared equal to a constant. Now some of you might be wondering, what does that mean? Something like this: x minus 3 quantity squared equals 6. That's a binomial squared equal to a constant, and can very easily be solved by completing the square. Yes? Technically, if you solve something like this, you'd be using 22.1b. 22.1b. Okay, then there's completing the square. Technically, what you learned in 22.2. In completing the square, you know that it's not factorable. You know that taking the square root doesn't work. This is what you do. You check to see if the coefficients are small. So, coefficients are small. Will not lead to many fractional terms. Say it again? Yeah. Or I can go back to it. It says will not lead to many fractional terms. And coefficients are small. You also, of course, if you're trying to complete the square, you want to make sure that the number in front of the x squared is something that you can take the square root of. So something like this. 4x squared minus 6x equals 3. Something like that. Where you can actually take the square root of 4x squared and get 2x. Right? That would be a situation where it might be best to complete the square. Yes? Coefficients are the numbers in front of the terms like x and x squared. So you don't want something like 56x squared. Okay, and the quadratic formula, last resort. Basically, you use the quadratic formula if everything else doesn't work. So, when it's not factorable, when you have larger terms, right? When you cannot take the square root of both sides and get an answer. So basically, it's when everything else doesn't work. We use the quadratic formula. So we're going to use this. We're going to use what we've written right here to help us to go through these problems. It says to identify the method of solving the quadratic equation, explain why you chose it, then solve. For this problem, the first thing that I'm going to do is check to see if it's factorable. Okay, so to do that, we first need to get it equal to 0. So 8x squared plus 9x plus 1 equals 0. That was by subtracting 1 to both sides. Now that I have it equal to 0, again I'm going to check to see if it's factorable. If it is, then I can go to my box and have it work out. So 8x squared, top left, 1 bottom right. Two numbers that will multiply to 8x squared. Add to 9x. Yes? What are two terms that will multiply to 8x squared and add to 9x? Yeah. 1x and 8x. 1x and 8x. So, did it work? Yes. It is factorable. And that's why we're going to use this method. 8x, 1x. 8x, 1x. I'll put the 8x up here. Technically, we can put it anywhere. And the 1x right here. Now, I don't want you to be thinking completing the square where we had to make sure we took the square root of 8x squared and put that to the left. Here we're actually going back to taking the GCF for the top row. What's the biggest amount I can divide the top row by? 8x. So 8x times 1x, or just x, is 8x squared. And 8x times 1 is 8x. And x times 1 is 1x. So this happened to be factorable, which is why we use the method of factoring. 8x plus 1 times x plus 1. So that's it factored. We still need to solve. Technically, we're still working within something that looks like 21.2. Okay, 21.2a. So you're going to see a little bit of review in this one objective. We're going to set both of these equal to 0. And we're going to solve. So subtract 1, subtract 1. That's 8x equals negative 1. The opposite of multiplying by 8 is dividing by 8. So x equals negative 1/8. That's one answer. The other one, nice and easy. X equals negative 1. So two answers. Negative 1 and negative 1/8. Those are the answers to the first quadratic equation. For the next one, what we're going to do first is check to see that it's factorable. If it's factorable, we'll go down that route. I'm going to subtract 2 to both sides to get equal 0. This is going to give me 4x squared minus 4x minus 5 equals 0. And I'm going to go to my box. This is a minus sign, by the way. 4x squared, top left, negative 5, bottom right. And I got to come up with two terms that will multiply to the multiplication of these two. That's negative 20x squared. That will add to give me negative 4x. Does it work? This one, you can spend some time on this, but you're not going to come up with two terms. Okay? So this is a kind of a frustrating objective because you try something, it doesn't work. So then you try something else. You're going to see that more and more as you go throughout your math classes here at DDHS. You try it, doesn't work, you try something else. So because this didn't work, our box and the idea of factoring doesn't help us. This isn't expressed as two-term or a binomial squared equal to a constant. We don't have c equal to 0. So taking the square root would not help here. Yes?
How did you know it would work?
I tried different terms, different numbers, and it would not get me there. Yeah. Good question. I knew that factoring wouldn't work because I tried everything possible, and it just didn't work. So now I'm going to use the method of 22.2, which is completing the square. To complete the square, we move our constants all to one side. So we have 4x squared minus 4x equals 5. You'll also notice, could I take the square root of the first term? Yeah, the square root of 4 equals 2. Right? So now I'm starting to really think, yeah, completing the square looks like the best idea. To complete the square here, never mind the 5 for now. 4x squared gets put at the top left-hand corner. And we set this up so it's a multiplication of two things to equal something that I don't know. I don't know what that something is. But I do know the part that it needs to add to because I have the number in front of the x. That's negative 4x. Remember that when completing the square, it's got to be the same thing that's added to give me the negative 4x? What's that? Negative 2 and negative 2. Good. Negative 2x and negative 2x. Yeah. This is completing the square. So this is 22.2 for a reference. Okay? If those two are the terms that added to negative 4x, then they also will be the two terms that multiply. And that gives me a positive 4x squared. And if 4x squared is the multiplication of these two, that means that these two terms need to multiply to 4x squared. Which means this number has to be 1. Good. Okay, now we can start putting things together. We do know that this is negative 2x and this is negative 2x. When it comes to completing the square, we take the square root of 4x squared and that's what we take out. What's the square root of 4x squared? 2. Yep, 2x. Don't forget the x. So 2x times 2x is 4x squared. 2x times negative 1 is negative 2x, and 2x times negative 1 is negative 2x. Yes?
Could you do negative 2x times negative 2x? So like both the left corner and the half. Instead of like positive 2x's, could you do negative?
Could I put negative 2x's right here and here?
And have the ones positive.
Keep it as positive. Keep it as positive. Just to be consistent with what we've been doing. So then we end up with 2x minus 1 times 2x minus 1. Hey, that's 2x minus 1 quantity squared. One thing that we forgot to do, though, is if I have this 1 that I'm introducing to this entire equation, I have to add 1 to the left side and add 1 to the right side. So this number ends up being what I add to the left side and the right side. So this 2x minus 1 quantity squared equals what the right side is. 5 plus 1 is 6. Now, I'll go through the process of completing the square by taking the square root. So, take the square root of both sides. Remember, that means that there's going to be two separate problems. One when it's a positive square root and one when it's a negative square root. So 2x minus 1 equals positive square root of 6. 2x minus 1 equals negative square root of 6. And then I add 1. Add 1. And of course, divide by 2. So x equals the square root of 6 plus 1 over 2. Make sure not to extend that square root sign. And similarly, x equals negative square root of 6 plus 1 divided by 2. Most people put the 1 out in front of the square root of 6 or negative square root of 6, but it doesn't really matter. Technically, both of these are considered correct. Now you can see why factoring would not have worked to come up with these answers. This is it.